Knowing the test command that allows us to check if a condition is true or false, we can conditionally execute only a subset of instructions from our script. The instruction that we will discuss in this lesson is if. It allows to execute sum of commands only if a given condition is met. The most frequently used syntax of this command is visible in the first line of the help. If commands. Of course, the commands here are usually not the real commands executing some actions on the system, but just a test program returning true or false. Then, commands. In other words, those are the instructions that should be executed if the condition evaluated by test was true. Optionally, the if statement can contain additional conditions that should be checked. Elif commands. So, if the first condition was false, the if statement will check another test given after the elif keyword. What will happen next? We give an expression that should be checked, and if it's true, the next part of the script is executed. But if the condition was false, the script continues with next elif check. Finally and optionally, the statement can be finished with else. Commands found here will be executed only when no other condition from if or elif was met. What is really special in Bash, the if statement begins with if and ends with phi. Let's suppose that we have to create a script installing application Finbook. We are in the team which is responsible for the development of the script, so let's start creating the script. Let's say the binaries of the newly installed application should be located in the directory var lib Finbook. That's why we can declare variable with such value. Now we can check if the directory already exists. In this case, we can use the test with the option D. This test checks if the file exists and is a directory. After if and the test, we need to write then. Then is a kind of a new instruction, that is why we put it into a new line. In a moment you will see that the entire if statement can be written in one line, but in such case the test and the word then must be separated with a semicolon. Okay, if the test succeeds, we don't need to do anything more. We will just display a message: the directory already exists. In other case, so when the directory is not existing, we will display message informing about actions that we take, and we will indeed create the directory. In this point, the conditional statement is complete, so we can close it with phi. A good practice is to return an exit code, so here we will return 0. Of course, that's a small lie, because for example the mkdir could end with error, and in such case we should also return an error. For the moment, please let's agree on such simplification. We will come back to this topic later. After changing permission to the file, we can start the test. Because the directory var lib is not writable for all the users, I need to start my script using sudo. If you are afraid about starting your own scripts with sudo, feel free to change the target directory to something less dangerous, for example your home directory. In such case, we could skip the sudo. As this is the first time when we start the script, the directory has not existed yet, and it was first now created. We will check in a moment, but first let's check the exit code. It's 0. Now we can check if the directory exists, and indeed it's present. So what will happen when I start the script once again? This time the script displays message saying the directory already exists. There is nothing to do. But let's make things more complicated. First, I will remove the target directory. And now, a surprise from a hacker. I will create a normal file named var lib Finbook. What will happen when I start the program again? It decided to create a directory and failed. Let's see into the code. At the beginning, we checked if the directory exists. There wasn't such directory. There was a file, but not a directory. So the script jumped into the else part. And here a message saying I will create a directory was displayed, and mkdir tried to create the directory. This operation finished with an error. To correct that situation, we can use additional test and another elif. Indeed, when the directory exists, and indeed it's a directory, there is nothing to do. But in the other case, we cannot just go to the instruction creating a new directory. In this case, we should ask if already exists a file object that is named like the directory that we want to create. That's why we add here the elif with test checking if exists a file named install_dir. Such kind of test can be done with the help of the option -e. So, if this condition is true, we will display message informing that a file named var_lib_finbook already exists, but it's not a directory, so the installation must be broken. To let know the user that something went wrong, we will exit from the script with status 100. 100 is just a number that we assign to such a failure reason, but that could be any non-zero number. Let's do another test. It seems that we managed to defend against the hacker trick. Let's analyze what has happened in the script. Our script tested if the install_dir directory exists. There was no such directory, so the script decided to go to the next test with elif keyword. Here the test checks if there is a file named like value of the install_dir variable. As such file existed, the script displayed the error message and exited with error 100. To check the exit code, we can run the script again, and immediately after execution we can check the value of exit code. Note that the exit code can be tested only just after the command execution. If I would test the exit code again, I would get value 0, success, but it means only that the previous command was successful, and the previous command was checking the exit code. Let's show another scenario of usage of if. We can do it in the currently developed script. Note that install_dir is a variable, but in this case it's more treated as a constant value. As it was entered at the beginning, it remains the same. That's something specific for our script, but very often such value will be passed to our script by the user as a parameter. Okay, when a value is sent by a user, we should never trust it. Someone could pass a stupid value here or start the script without passing a valid parameter. It would be good to test the value. We are still at the stage where we don't know how to work with parameters, but it's a topic for one of the future lessons, so don't worry. For the time, we can write the code checking that variable. How can we validate install_dir? First of all, it should not be empty, so let's write such a test. We will use test-z. As we are using here double square bracket, we don't need to add the quotes around the variable name. After the test, we can write semicolon and next the word then. Till now we always wrote the then in a separate line, but this made our script too long. Such syntax is more compact. That's a typical usage for the semicolon. Normally in Bash, it is used to separate instructions that are written in one line but should be executed one after another. So what to do if the variable is empty? We will display an adequate message and exit the script, this time with the exit code 101. To close the conditional statement, I write the word "fi". Currently install_dir is defined correctly, so when I run the script, the recent message should not be displayed. Indeed, the displayed message is not the one recently added. It's time for another test. I will comment out the line with the variable definition. Now the variable is not defined at all. And what would happen now? Now we have error install_dir cannot be empty. Our additional if statement was executed and the script defended against a potential error. We can also check the exit code, and it is 101. As you can see, if allows to execute only part of the commands present in the script. The easiest syntax would contain only the if condition and the commands that should be executed. If there are more possible conditions and actions, multiple elif sections can be added. Each of those sections should contain its own instructions that should be started. Finally, at the end, we can use else. Here, there is no additional condition to check. Else should be executed when no other condition from if or elif was met. Elif and else are not mandatory, what we can see in the first conditional statement in our script. Here we have only the if. But there is much more scenarios of working with if, and you can learn them in the next lesson.